Hello everyone, welcome back. And today we're gonna start with the new topic, which is the chapter 5, logarithm and exponential function. And today we're gonna start with some exponential function first. Um, if you say some functions with a to the power of x, and also a is a positive number, and that's called exponential function, but except for one. So if a equal to one, that's pretty much like everything is one. So and we can see the graph is different. If a is greater than one, and you can say the graph is going from low to high, and also we have something is called the asymptote, which is we cannot touch on the x value, which is which is y cannot equal to 0. And the graph function of the a to the power x from 0 to 1, we can say is from high to low, which means we still can't have the y equal to 0 because we're never going to be touch on the 0. So key values, if f equal to -1, so that become to 1 over a. So that's the index law, a to the power of 1 equal to 1 over a. And if x equal to 0, that equal to 1, which is fantastic. And if x equal to 1 and function equal to a. Maxi domain, which is the real number. And the range only can be the positive number. Okay, and x-axis is the horizontal asymptote. All right, and then we're gonna doing some transformations. So you can see if you do the translations, x can plus or minus h, and y can plus or minus k. So you can from a region one y equal to a to the power x to imagine to the equation 2 a to the x minus h and plus k. And I will show you the horizontal asymptote is actually equal to y equal to k, so which is the last number. A range for the image will be from k to the positive infinity. Okay, and let's try to have a look at the sketching the graph and together. For this one, we can explain something with the transformations. First thing we could say, y equal to 2 to the power x, that's the original one. Translated 1 unit in the positive direction of x-axis, and 2 units positive direction of the y-axis. That's it. So that's how you transform it. And then we could do drawing the line like that. Perfect. And we're gonna find the first thing is a asymptote. So can anyone tell me the asymptote is? It's k, right? So we could say y equal to 2 is horizontal asymptote. And we're gonna draw the 2, so which is horizontal asymptote. And we're gonna find a y-intercept, which is x equal to 0. So y equal to 2 to the power negative 1 and plus 2, so which is 0 over 2. Actually, no, 5 over 2. 5 over 2. Yeah, so which is 2.5 around, and then we can find another extra point. So when x equal to 1, so y equal to 2. So x equal to 1, y equal to 3. Yeah. Did I say 2? Sorry. It's x equal to 3. Yeah. And then going the curve, and that's y equal to x to 2 to the power x minus 1 plus 2. Perfect. All right. Make sure you have 2 or 3 points. And also we're gonna figure out this range. So range is from 2 to the positive infinity. That's your k to the infinity. Okay. Perfect. And reflection is actually you are going to the opposite. So you flip from the x-axis or horizontal azimuthal, and you will see the difference. So reflected in the x-axis, so that's called reflection. Which means x still the x, but y become to negative y. So which means when a to the power x, that become to a negative a to the power x. And after that, horizontal azimuthal still y equal to 0, and then the range from negative infinity to 0. Let's try some examples and then to give us some hints. Okay, so reflect to the x-axis, and then first thing first, let's figure out when x equal to 0, y equal to a negative 1. Okay, so we know horizontal azimuthal still is y equal to 0. Y equal to 0. So let's try with x and y. So, and let's try when x equal to 2, y equal to negative 9. And when x equal to negative 1, so y equal to negative 1/3. So we just keep going. And we can say this one is negative 1, 0, negative 1, 1, negative 3. So we just keep going that way. Yeah. Perfect. And that's the reflected. And the range is negative infinity to 0, but not gonna including 0. And now we're gonna do something reflected by the y-axis. So now we actually from a to the power x become to a to the power of negative x. And you know, once you had a power is negative, that actually become to 1 over the a to the power x. Still, horizontal is y equals 0. Horizontal azimuthal is y equals 0. And range gonna be from 0 to the infinity. And let's have a look. When x equal to 0, y equal to 1. When x equal to negative 1, y equal to 6 to the power negative 1, so equal to 6. And we can say if x is keep going negative, they going up. And if the x equal to 2, and they closest to 0, so we can say negative 2, so which is 1 over 36. So our graph will be looks like that. Hopefully x, y, so you can able to know. And that was 0, 1, and they going from negative 1 to negative 6. sorry, 6. Negative 1 to 6. And negative 1 0. And we're going to keep going that way. Going that way. Uh-oh, sorry. Yeah. Yeah, perfect. And then that will be y equal to negative 6 to the power of negative 6. 6 to the power of negative x. And then range is equal to infinity, 0 to infinity. All right, perfect. And that's it. And we're going to learn something called dilation. All right, dilation from x-axis. So we're going to start with dilate by the k, the y being dilated. So which is y equal to k to the power of k a to the power x. And still the horizontal is y equal to 0, but the range is still the same. So it's 0 to positive infinity. And let's have a look how we do this question. If I got y equal to 3 times 5 to the power x, first thing first, let's figure out with when x equal to 0, y equal to 3. So 0, 3. That's our y-intercept. And when x equal to 1, y equal to 15, so we can say it's going up. And when x equal to negative 1, so that equal to 3, y equal to 3 over 5. So, and our perfect diagram will be looks like y and x, that will be from negative 1 and 3 over 5, and then 3, 0, 3, and 1, 15, which is in here. So that'll be like that. That'll be like that. Yeah. So the graph is actually it's bigger to leave the x values. So that's range is from 0 to positive infinity. Alright, the last couple, so we can try is something is factor with y-axis. So now we actually dilate by y-axis, and then the asymptote that become y equals 0. So let's try this question then. When x equal to 0, y equal to 1. When x equal to 1, y equal to 3. Because it's 9 to the half, that's the square root of 9, that's 3. And when x equal to negative 1. So what happened to negative 1 then? So that's equal to y equal to 9 to the negative half. That's square root of 9 over 3. That's 1 over 3. All right, perfect. We figure this out, and then we can draw the graph. You can say every single time I always start with y equals 0, which is, if you can do the same thing, because you can find your y-intercept straight away. And pretty much like that. And that's 2. That's a 2, 9. And that's 1, 3. 1, 3. And that's a negative 1 and 1/3. Perfect. Yep, that's called the dilation of y-axis from the y-axis. And last example, so we can do some combined. I want you guys to try by yourself for this one, and let me know if you have any question. And they can be to be your homework if you can. Okay, so let me know if you have any questions. So this is all for today, and we actually gonna do example 6 during the class as well. So please try it beforehand. All right, see you guys next time.